Well, hello friends, welcome back to C4U. This video is about Birch reduction, and in this video we will go through the mechanism of Birch reduction and some conditions like if you have electron withdrawing group then what to do, and if you will have electron donating group then what to do, and yeah, as well we are going to see some examples. Okay, so now let's start. Before directly going to the reaction, we will see some reagents which are used in Birch reduction. Basically, alkali metals like sodium or lithium are dissolved in liquid ammonia. This is what the basic solution used to use for the Birch reduction. Okay, so okay, we know alkali metals like sodium and lithium have a single electron in their valence shell, and they lose these electrons while in the solution, and these electrons get surrounded by the ammonia molecules. This is what the theory about Birch reduction. We will just see in the brief. When you practically perform a Birch reduction after dissolving these metals into liquid ammonia, the solution gets deep blue color or deep red color. Okay, so this color is due to this kind of ammoniated electrons. We call these species as ammoniated electrons, and these electrons are going to play a main important role into the Birch reduction. Now let's go to the reaction. So basically the Birch reduction is nothing but preferably known as partial reduction of aromatic rings. For example, say benzene with sodium in liquid ammonia gives you, what it gives you? A partial reduced ring which has to be non-aromatic. Okay, partial reduction means out of 6 carbons, only 2 carbons are being reduced which are para to each other. These 2 carbons, whereas sp2, sp2 are being transformed or are being reduced to the sp3 carbons, and this aromatic ring has been transferred into non-aromatic. You can't see any conjugation here, so it is non-aromatic. We'll see. Okay, so, and yeah, this example or aromatic rings are very much famous for the examples of Birch reduction. But guys, one must know, okay, these kind of species which we call as alkynes are also reduced in this kind of a system. Okay, so let's take an example of 2-butene is being reduced to 2-butene, but whether it has to be cis or trans, always remember Birch reduction gives trans alkene from alkyne, so we are getting trans 2-butene. Okay, so this is what the reaction. Now let's go to the mechanism. In the mechanism, as we discussed above, these electrons play an important role. So how it goes, let's see the mechanism with benzene only. So here we have the electron of sodium, let's say like this. This electron is being transferred to one of the carbon. This electron approaches to one of the carbon, and these pair of electrons, which is nothing but the bond, shifts to the another carbon. So here we get something like this. Two unstable species adjacent to each other make the whole structure, whole ring unstable, so that undergo resonance and bomb formation and deformation takes place, and here we get something. Okay, this is what the case. Yeah, I must have to say here, in some cases or in some books, in some examples, you might have been seen with these kind of reagents they use some polar protic solvent like ethanol or maybe any alcohol. The basic thing behind using these solvents is to promote a reaction, to increase the rate of reaction. So that comes into picture here, like this one. So the hydrogen is being grabbed with this anion, and here it becomes stable one. It has already a one hydrogen here, and the new one is coming here. In absence of this ethanol, this must have been told. Okay, with Na in NH3, it forms a kind of this thing also, and the remaining hydrogen comes here, which takes some time, and the reaction becomes slow. In presence of alcohols, reaction goes faster. So we'll see the same one. Now here another electron from a sodium comes here, forms another anion, and yeah, another hydrogen with C2H5OH, and here you are getting the product which is described above. So this is what the partial reduction. Okay, now let's go for the mechanism. Sorry, I mean, let's see if we will be having electron withdrawing group or electron donating group. For the example of electron withdrawing group, let's say we are having something like NO2. Perfect, yeah, right now NO2 we are having it here. And with electron donating, let's say we'll be having, yeah, methoxy, yeah, OMe. Fine. So basically the orientation in such a electron withdrawing and electron donating group depends on the stability of a carb anion which is being formed. For the simple benzene, all 6 carbons are same, so at any carbon you can form your anion. Okay, but in these cases, if an ion is being formed here, the electron withdrawing group will stabilize it, and if that anion is being formed here, then this won't be able to stabilize it, rather it will destabilize it. Okay, so for this kind of a thing, if you will give NaNH3, so basically the electron will approach to this carbon, so radical would be formed here, and NH2, a negative charge. With this, with another hydrogen, you will get, yeah, something like NH2, one more radical. So first, now you know the net mechanism, so we'll directly jump to the final product. I mean NO2, yeah, sorry, NO2, sorry. So we are getting this kind of product in case of electron withdrawing group. Okay, now in case of an electron donating group, if we will see, anion cannot be formed here, so the coming electron, it will approach this carbon, right? So if it will approach this one, so let's say here goes OMe, here goes radical O and R, and here an ion is being formed. Mechanism you know, and rest we skip the rest of steps and we'll directly jump to our final product, which would look like this one. Okay, so this is the basic difference between electron withdrawing group and electron donating group if it is present on the benzene ring, and if you are given with the Birch reduction conditions. Along with this, you might be provided with ethanol or methanol or any alcohol which is just used as a promoter. Okay, so now next we'll go for some examples. So here is our example. This question was asked in CSIR NET examination, Chemical Sciences, June 2017. So the quinoline given with sodium in liquid ammonia, what would be the product? Without looking at the options, we will go with our mechanisms and our knowledge of this Birch reduction reaction. Okay, so first I will directly draw the product. and then you think yourself whether it is right or wrong. Okay, so this is the product. Now pause the video, make the mechanism on yourself. Okay, so hope you did it. Now let's see the mechanism. To see the mechanism, the electron from the valence shell of the sodium approaches this carbon, the bond shifts here, becomes negative charge, and then with the resonance, the negative charge go on nitrogen, which is the stable anion, because the negative charge is on electron withdrawing group. Sorry, the negative charge is on electronegative nitrogen. And then with the rest of mechanism, this is what the final product which I draw here. So I hope all of you got this. And yeah, in some of the books the mechanism have been might shown as like, we'll take with a simple benzene. uh, Sorry, I must have told it previously. In the influence of electron, from sodium, these bonds undergo homolytic fission, forms such a kind of radicals, and then electrons come here, and then it make a negative charge. So it doesn't make any change to our next mechanism. So guys, don't worry, just do it at your own. I have one more question for you. So this 2,6-dimethylpyridine is given with a sequence of 3 reactions: lithium in liquid ammonia, then H3O plus means hydrolysis, and potassium hydroxide with methanol. These are the 4 options. Okay, so guys, this is again a question from CSIR NET examination. It may be, I think, from 2012 chemical sciences. I'm not gonna solve this at this moment. Just solve it, take your time, and in my next video I will come up with this solution and many more examples from the CSIR NET examination on Birch reduction. Till then, just enjoy your chemistry and stay tuned. Thanks for watching.